Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today is day one of inverse functions. We will have a video of inverse functions tomorrow as well. It is important to note that in Algebra 2, we are only going to consider inverse functions of two types of functions. Type letter A is a set of ordered pairs. The inverse of a set of ordered pairs is really easy. And the inverse of linear functions. All linear functions have inverses. And we will have an entire unit of study next year in pre-calculus about inverse functions that are not linear. Okay, so let's jump in about what the world is an inverse function. So here's our definition of what an inverse function is. Keep in mind, if you ever need to pause the video to write your notes, I certainly would do that. The video is going to be about 20 minutes. You have certainly plenty of time to pause the video and write the notes because you will need these notes. So let's jump into the definition of an inverse function. So if I have two functions, f of x and g of x, they are inverses of each other if and only if f of g of x is equal to x as well as g of f of x. And if you recall from some of the assignments earlier, we were talking about some inverse functions. We didn't call them inverse, but we did find these compositions, and they both equaled x. So this is the analytical definition of inverse functions. If f of g is x and g of f is x, we say f and g are inverses of each other. This is an extremely important definition. This is probably a 5-star definition. Okay? Sometimes we will refer to this inverse, this thing we're calling g of x, as f, this -1 there, it's not an exponent. Don't think it's an exponent. All that is the notation for the inverse. And if I see that, the way I read that is the inverse of f. So when I see this guy right there, well, I say, oh, that's the inverse of f. Here, and most of the time in mathematics, we're going to call that an inverse because this notation is so, it's just weird. Sometimes we're just going to say, hey, you know what? G of x is going to be the inverse. But just keep in mind that g of x is this guy, f to the -1 power, which really isn't a power. What the heck happened here? Okay, so right here. All right, so I think some of the assignments use this notation, f inverse. Most will just use g of x. So let's get to this example here. Example number 1. F of x is 1/3 x plus 2. G of x is 3x minus 6. My question is, are they inverses? Are they inverses? Well, no, let's check. What we're going to do is we're going to jump up here and we're going to use the definition. Keep in mind, we're going to use both ways. We're going to do f of g and g of x. Let's check it out. Okay, so let's f of g, wherever I see x and f, I'm going to put g. So I'm going to put g in this guy right here. So 1/3 times g plus 2, 1/3 times 3 is 1/3 times 3 is x, 1/3 times 6 is -2, plus 2 is x. Whoop, check OK. Now let's do g of f of x. You should be handy at doing this because we did it so much last week and early in the week. So now we're going to do g of f of x. Wherever I see x and g, I'm going to put f. So here's my x right here. I'm going to put f in there, 1/3 x plus 2. This is f. I'm saying that is f. And so now I just do some simple arithmetic. 3 times 1/3 is x. 3 times 2 is 6. Minus 6 is x. So yes, since f of g is x and g of f is x, we can say that f of x, 1/3 x plus 2, and g of x, 3x minus 6, are inverses because the definition checked. Okie dokie. Let's go to the next page here. And so here, Ooh. So here's the question then. How do you find an inverse function? How did I, if I go back here, how did I come up with this inverse function here? How do I know that? Did I just pull that out of, no, I didn't just pull it out of the air or pull it out of my nose. There's an actual method to find this inverse, and that's what this slide is going to tell us to do. And I have outlined these steps. These are going to be the same steps that we use next year in pre-calculus. Okay, so what we're going to do is step through how to find the inverse of a function. And what we want to note here in Algebra 2 is that all linear functions have inverses. Well, provided we're not talking about this constant function, provided that m does not equal 0, all linear functions have inverses. Okay, so here I'm going to find the inverse of this linear function 4x minus 3. F of x is 4x minus 3. This is linear. And what I'm going to do is find the inverse. Step 1, and you better write these steps down. You better pause the video. Step 1 is put y in for f of x. So instead of f of x, I put y. Step 2 is to solve for x. Pretty easy. Add 3. Y plus 3 is 4x. Divide by 4. Multiply both sides by 1/4. 1/4 times y is 1/4 y. 1/4 times 3 is 3/4. 1/4 times 4x is x. Bam. I have solved for x. You notice I have x. I have solved for x. Step 3, swap the x and y's. So wherever you see x, put y. Wherever you see y, put x. Oh, x becomes the y. Y becomes the x. So y is 1/4 x plus 3/4. That's after step 3. Step 4 is simply let y equal g of x. Get out there. Get out there. That's supposed to be somewhere. I don't know where it is. Okay, so step 4 is let y equal g of x. So bam, there's my inverse. So I found the inverse. These are important, very important steps. Okay, here's your steps. Step 1, put y in for f of x. Step 2, solve for x. Some algebra. Step 3, swap the x's and y's. This step 3 is how we're going to find the inverse of ordered pairs, and I'll go through that in a bit. Step 3, swap the x and y's. Step 4, simply let y equal g of x, and now I have found the inverse. But what do you think I'm going to do? As I've done a lot, I'm going to check my answers. So I'm going to find f of g. F, I'm going to recall that f was 4x minus 3. So I'm going to write this here. Recall that f of x is 4x minus 3, and this g of x that we just found is equal to 1/4 x plus 3/4, and now I'm going to check the definition. So f of g, wherever I see x and f, I'm going to put g. Right here is g. I'm going to do the distributive property. 4 times 1/3 is x. 4 times 3/4 is 3. Minus 3 is x. Check OK. Find g of f wherever I see x and g. Right here. I'm going to put f. This is f. Do the distributive property. 1/4 times 4 is x. 1/4 times -3 is -3/4. Plus 3/4 is x. Bam, there you go. Check OK. So these functions are indeed inverses of each other. So the work that I did was correct. I actually correctly found the inverses. Not difficult. Won't be able to do this without the notes, though. Okay, here's an interesting. The next slide is going to show us. The next slide is going to show us. The next slide is going to show. Whoa, dude. The next slide is going to show us an interesting property about inverse functions. So let's do a couple new functions. 1/2 x minus 2. 2x plus 4. Let's check to see if they are inverses. Okay, we've done this a lot. F of g, wherever I see x and f, I put g. So 1/2 times 2x plus 4. 1/2 times 2x is x. 1/2 times 2 is 2. Minus 2 is x. Check OK that way. G of f of x. Wherever I see x and f, I'm going to put g. Wherever I see x and g, I'll put f. 2 times 1/2 is x. 2 times 2 is 1, negative 1. And so I have x. 2 times negative 2 is negative 4. And so I have x minus 4 plus 4 is equal to x. So they are inverses. So now I'm going to very carefully graph f of x. I'm going to very carefully graph 2x plus 4. Let's graph f of x, 1/2 x minus 2. So I'm going to go to negative 2. What I'm doing is graphing f of x, negative 2. I go up 1 over 2, up 1 over 2, down 1 back 2, down 1 back 2, and this is the graph of f of x. I'm going to very carefully graph the function 2x plus 4. Okay, what am I going to do? I'm going to start at 4. I'm going to go up 2 over 1, up 2 over 1, or back 2, back, down 2, back 1, down 2, back 1, and this is the graph of g. And then what I'm going to do is I'm going to graph this line y equals x, the world's most famous line. And I should see this artistic work here that has created when the blue line is reflected across the yellow line. If I fold the blue line across the yellow line, what do I get? The red line. And that's an important property of inverse functions that we'll talk a lot about down the road. Inverse functions are reflections of each other across the line y equals x. So this only works if you carefully graph the inverses. So you have to be very carefully and graph those functions. And if you very carefully graph them, you're going to see that they are reflections of each other about that line y equals x. This is a beautiful property in mathematics, actually. Okay, so what we're going to do now, we're going to, the next slide is going to talk about the inverse of a set of ordered pairs. So here I have a set of ordered pairs. I'm going to put the screen hider on there. I have a set of ordered pairs, 1, 5, 2, 7, 3, 11, 4, 9. And I'm going to go back to those steps that I said to find the inverse analytically. And I'm going to go back to, as I was referring to earlier, where you swap the x's and y's, the x becomes the y's become the x. If I look at this, if I go to this, guess what you're going to do? You're going to recall the step where you swap the x and y's, and the inverse is simply yes, it is that easy. The x becomes the y's become the x, this 2x becomes the y. All you're doing is swapping you get the xy becomes the yx, and this is your new xy on your inverse. All you do is swap the x's and y's. This x becomes a y, this y becomes an x, and that's the inverse. And I want to tell you, that's how easy it is to find the inverse of a set of ordered pairs. So let's get that out of there. Okay, not a very long video, not a very difficult topic. Going to be difficult if you don't watch the video. What I'm going to do now is I'm going to go through and I'm just going to look at every slide that we did. And if you need to pause the slides and take a picture, you can, because you need these notes. Slide 3, this was slide 4, where we graphed the lines. We had two functions, determined if they were indeed inverses. And we saw that the inverse was the reflection. The inverses are reflections about that line y equals x. And then slide 2 was how you find an inverse, and we're only going to find the inverse of linear functions right now. And I had the steps, step 1, step 2, step 3, step 4. Once we found the inverses, we did indeed check them. And then if I go to slide 1, what did we do? Well, this was big right here. Came up with the analytical definition of inverse functions. F of g is x, which is equal to g of f of x. If that happens, then the functions are inverses. And then all we did was check. I gave you two functions, and we checked that indeed they were inverses. And I will guarantee you, in Algebra 2, we are only going to look at the inverse of set of ordered pairs and the inverse of linear functions. So that's a nice quick little video. I will have a video over the same topic tomorrow. And now I will bid you farewell.